You've eaten this chip more times than you can count. But what you're holding right now isn't just a snack. It's the final result of one of the fastest, most controlled food systems on Earth. This single, thin slice of potato passed through over 100 machines, was measured down to fractions of a millimeter, and traveled from farm to factory to a sealed bag in less time than it takes to watch this video. And here's the part almost nobody knows. Lay's doesn't use normal potatoes. They test tens of thousands of potato varieties every single year just to find the few that crunch the right way. Too much sugar? Burnt. Too much water? Greasy. Wrong thickness? No crunch. Every failure is eliminated long before the oil ever heats up. So today, we're stepping inside a system that runs almost 24 hours a day, moves 500,000 pounds of potatoes daily, and turns muddy vegetables into one of the most addictive snacks on the planet. This isn't cooking. This is precision engineering. This is how Lay's potato chips are made. Chapter 1. The potato you'll never see in a store. The story of a Lay's chip doesn't begin in a kitchen. It doesn't even begin on a farm. It begins in a lab. While most potatoes are bred for boiling, baking, or mashing, chips demand something completely different. For chip making, sugar is the enemy. Sugar causes chips to brown too fast, taste bitter, and burn under high heat. That's why the vast majority of potatoes grown around the world are actually terrible for chips. This is where the science begins. Every year, agricultural scientists test over 45,000 potato varieties just to find the few that meet Lay's standards. 45,000. And out of all of them, only a tiny fraction survive. Lay's approved potatoes must be low in natural sugar, high in starch, dense in structure, and uniform in size. These potatoes aren't sold in stores. You'll never see them labeled. They're grown exclusively for one purpose: crunch. And every single potato is tracked. Lay's knows which farm it came from, which field it grew in, when it was planted, and exactly when it was harvested. This isn't traditional farming. It's controlled agriculture, designed backward from the crunch. Chapter 2. Farming at industrial scale. Across the United States and Canada, Lay's sources roughly 4 billion pounds of potatoes every year from around 165 contracted farms. Planting begins in spring. Harvest peaks in summer. But this isn't a slow, gentle harvest. Specialized machines dig nearly 10 inches underground, lifting entire potato plants in a single sweep. Roots, soil, rocks, everything comes up together. The plants ride onto vibrating conveyor belts that shake away debris while sorting up to 40,000 potatoes per minute. Per minute! And in hot regions like Florida, timing becomes critical. If potatoes stay underground too long in extreme heat, they can literally begin cooking in the soil. That's why Lay's logistics teams work on a strict clock. Nearly 40% of harvested potatoes go straight from the field to the factory in less than 24 hours. The remaining 60% take a very different path. Chapter 3. Potato Hibernation Chambers. Not all potatoes are needed immediately. To keep chips flowing year-round, Lay's places most of its harvest into storage, but not normal warehouses. These facilities are designed to pause biology. Inside these massive storage barns, the temperature stays locked at 45 degrees Fahrenheit, humidity holds at 85%, and light is almost completely eliminated. In this environment, potatoes don't grow. They don't sprout. They don't age. They sleep. Some of these facilities can hold up to 40 million potatoes at once. They may rest here for weeks, sometimes for months, all waiting for one signal: the factory call. Chapter 4. The load to fry race begins. When a Lay's factory places an order, everything speeds up. Forklifts move massive wooden crates from storage onto conveyor systems leading to the wash area. The potatoes slide into fast-moving water flumes. Rushing water strips away soil. Rotating brushes scrub every surface. High-pressure jets rinse them clean. But here's a detail most people never hear about. This water isn't wasted. Modern Lay's facilities use closed-loop water systems. The water is filtered, potato starch is captured for reuse, and the same water cycles back through the system. Because of this, it now takes less than 5 liters of water to produce 1 kilogram of potato chips. Once clean, the potatoes are loaded into semi-trucks. From this moment forward, the clock is ticking. Lay's targets a strict deadline: load to fry in under 24 hours. Which means the potato you're about to eat may have been underground just yesterday. And the moment those trucks arrive at the factory gates, the most intense part of the process begins. Chapter 5. Arrival at the factory. The moment the trucks arrive, there is no stopping. No workers with shovels, no waiting in line, no time to breathe. Each massive trailer backs onto a hydraulic platform. The platform slowly lifts, tilting the truck forward to nearly 30 degrees, and then gravity takes over. Thousands of potatoes spill out at once, rushing downward, colliding gently, rolling onto conveyors that vanish into the factory. From this moment on, the potatoes never stop moving. This factory runs almost continuously, day and night, week after week, because demand never sleeps. A single large facility can receive 18 truckloads every day. During peak season, even more. But before a single potato earns the right to become a chip, it must pass science. Chapter 6. The buoyancy test. Right after unloading, workers pull random samples from the conveyor. These potatoes don't go forward, they go into water. Using a device called a hydrometer, technicians gently lower potatoes into a water tank and watch how they float. This simple test reveals something critical: the flesh-to-water ratio. Why does that matter? Because this ratio determines how quickly moisture escapes, how much oil gets absorbed, and how crispy the chip will feel. Too much water? Greasy chips. Too little water? Dry, brittle, overcooked. The numbers from this test are sent directly to the fryer's control system. Cooking time and temperature are adjusted batch by batch. At the same time, another sample is sliced and fried in a test kitchen. Technicians inspect color, texture, and sugar content. Potatoes with excess sugar caramelize too fast, turning dark and bitter. Thanks to Lay's proprietary potato varieties, most batches pass smoothly. Only after clearing these tests does the line move forward. Chapter 7. The second wash. Even though these potatoes were washed at the farm, they're washed again. This isn't about dirt anymore. It's about protecting the machines. Even tiny bits of grit could damage peeling equipment downstream. So the potatoes pass through another high-speed wash. Powerful water jets blast every surface. Rotating brushes knock loose anything stubborn. Filters catch debris before it travels further. Now, the potatoes are factory clean, and the skins come off next. Chapter 8. Peeling millions per day. The potatoes roll into massive peeling drums. Inside, the walls are lined with coarse, abrasive material. As the drums rotate, the potatoes tumble, rubbing gently but relentlessly against the surface.
Rotation steady.
The skins peel away. At the same time, water jets wash the loosened peels out of the system. This process is aggressive, but incredibly fast. 6 peeling machines working together can process more than 4 million potatoes every single day. The discarded skins aren't wasted. They're collected and reused for animal feed or compost. What emerges next are smooth, pale, raw potatoes, ready for inspection. Chapter 9. Optical sorting in milliseconds. As soon as peeling ends, the potatoes pass beneath high-speed cameras. These cameras don't blink. They don't miss. They analyze color, shape, and surface condition in real time. In just milliseconds, the system detects bruises, rot, or dark spots invisible to the human eye. When a defect is spotted, a mechanical finger snaps out, flicking the potato out of the line mid-air. Rejected potatoes drop into a separate chute, redirected for other uses. Scan, decide, remove. All faster than a human blink. Only perfect potatoes continue. Chapter 10. Size control is everything. Even perfect potatoes aren't ready yet. Size matters. The potatoes roll onto rotating screw conveyors made from durable plastic. As they move forward, smaller potatoes slip through gaps. Larger ones remain on top. Why separate them? Because uniform slicing requires uniform size. Oversized potatoes are automatically split in half by heavy-duty blades. Now, everything entering the slicers is nearly identical. Consistency here creates perfection later. Chapter 11. The slice that defined the chips. This is the moment where potatoes become chips. They drop into spinning drum slicers. Centrifugal force flings each potato outward against razor-sharp blades mounted along the drum wall. In a fraction of a second, one potato becomes 30 to 40 slices. Each slice measures just 1 to 1.5 millimeters thick. That thickness is everything. Too thick? Hard. Flat? Unpleasant. Too thin? Folded. Fragile. Uneven. The goal is the perfect saddle-shaped curve. Straight blades carve classic chips. Zigzag blades create ridges. Workers constantly measure thickness using precision gauges. Here, fractions of a millimeter matter. Chapter 12. De-starching the hidden step. Fresh slices slide into flowing water channels. They're washed once, then again, then sprayed from above. This step removes surface starch. Without it, chips stick together, fry unevenly, and absorb too much oil. After washing, powerful vacuum systems pull away excess moisture. Dry enough to fry, wet enough not to burn. Now comes heat. Chapter 13. The continuous fryer. The slices plunge into a 40-foot-long continuous fryer. Oil temperatures range between 320 and 350 degrees Fahrenheit. The slices ride through the oil on a submerged conveyor. Average frying time? About 3 minutes. Inside the fryer, water turns into steam, steam escapes, and oil replaces it. This exchange creates crispness. Lay's carefully manages oil chemistry. The oil is always balanced at roughly 50% fresh, 50% used. All fresh oil would feel greasy. Too much used oil would taste wrong. Balance creates the crunch. As the chips rise out of the fryer, they're golden, crispy, and incredibly fragile. From here on, even gravity must be gentle. Chapter 14. Why everything vibrate. Fresh out of the fryer, the chips look strong. They're not. At this stage, one hard drop, one sharp edge, and the chip shatters completely. That's why almost nothing inside this factory moves the way you expect. Instead of smooth conveyor belts, Lay's uses vibrating conveyors. Not shaking violently, just enough to keep the chips drifting forward without ever crashing into a hard surface. Even ladders, transfer points, and drops are designed to gently vibrate. If traditional belts were used, you'd open a bag and find nothing but crumbs. And nobody wants that. Chapter 15. Optical chips sorting. Even now, the inspection isn't over. The chips pass under another set of eyes. Eyes that never blink. High-speed optical scanners analyze more than 400 chips every second. They're looking for dark spots, burn marks, uneven color. When a flaw is detected, a pinpoint blast of compressed air fires. The defective chip is launched out of the stream mid-flight. No hesitation, no second chances. This happens faster than your brain can register it. That's why when you open a bag of Lay's, almost every chip looks exactly the same. Chapter 16. The Seasoning Rocket Drum. Now comes the part everyone remembers. Seasoning. Still warm, the chips slide into a massive rotating drum. Inside, they tumble endlessly, forming a flowing golden waterfall. This drum is sometimes called the seasoning rocket, and once you see it, you'll understand why. As the drum spins, a tube inside sprays seasoning with perfect timing. For classic chips, fine, precise salt. For flavored chips, custom blends using real ingredients. Seasoning sticks best while the chips are warm. The oil becomes a bonding layer, locking flavor onto both sides. Lay's now produces over 200 flavors worldwide. Some chips come out flat, others come out folded. Those folded chips, they used to be mistakes. Now, they're favorites. Chapter 17. Human Taste Control. With all this technology, you might think machines decide everything. They don't. Twice every shift, a group of employees is randomly selected. Engineers, line workers, managers, custodians. They taste the chips straight off the line. Each batch is compared to something called the golden bag. The golden bag defines salt level, crunch, aroma, mouthfeel. If anything feels off, even slightly, adjustments happen immediately. This is why Lay's tastes the same every time you open a bag. Chapter 18. Bagging at light speed. Once seasoned, the chips rise upward to the packaging floor. Here, everything accelerates again. Multi-head weighing machines, some with 115 digital scales, calculate portions in milliseconds. 30 milliseconds. That's faster than blinking. The chips drop into printed bags, and before sealing, something invisible happens. Nitrogen. The bag is flushed with nitrogen gas, not air. Nitrogen prevents oxidation, keeps chips fresh, and creates the cushion that protects them during shipping. That air in your bag? It's not cheating you, it's protection. Chapter 19. Robots, pallets, and silent logistics. Sealed bags move to the boxing area. Some factories use human hands, others use robots. Robotic arms with soft suction cups lift and place bags with precision. Strong enough to grip, gentle enough not to crush a single chip. Boxes stack automatically. Pallets are wrapped tightly. Automated vehicles glide through the warehouse, moving pallets toward loading docks. Chapter 20. Why Lay's addictive. Now comes the part most people never think about. That famous slogan, "Bet you can't eat just one." It isn't a joke, it's engineered. Lay's chips are built around dynamic contrast. A loud crunch at first bite, then rapid breakdown, then a clean finish. Salt hits fast, then fades quickly, making your brain want another bite. The thin curve increases tongue contact. The oil balance feels rich, but not heavy. Each bite ends just soon enough to make the next one feel necessary. Chapter 21. Why this system hard to copy. Many brands try to copy Lay's. Most fail, not because of recipes, but because of scale. Lay's depends on custom potatoes, farm contracts, 24/7 factories, real-time data, and logistics timed to the hour. Miss even one piece, and the system breaks. That chip in your hand isn't simple. It survived science, speed, machines, and human judgment. All so that one moment, that single crunch, feels perfect. So next time you open a bag of Lay's, remember what it took to get there. And be honest, can you eat just one?